Hello, good afternoon. My name is Dana, and we will talk about the article titled Impact of Nitrogen Fixation Bacteria on Nitrogen Fixation Efficiency of Bambara Ground Genotypes. I will tell you a little about the introduction and discusses how inoculation of a Bambara peanut genotype with Bradyrhizodium japonicum trait affects nodulation and nitrogen fixation. Nitrogen fixation is a necessary process for sustainable agriculture, so it is imperative to reduce nitrogen fixation. They depend on chemicals, fertilizers. Some important points is nitrogen is essential for plants, but can only be absorbed in the reactive form, a process such as Haber boson or biological fixation convert nitrogen to ammoniac. Soil microorganisms receive support plants, and nitrogen fixation should be associated with rhizomes and legumes. Um, Next, the biodiversity of BGM, Streptococcus microbacteria in Africa is poor. The objective of the study, the main objective was to evaluate the response of different genotypes of Bambara peanuts to inoculation with different strains of B. japonicum, taking into account geographical and sensory difference. In the materials and methods, selection of genotypes and bacterial strains, various BGN genotypes known for their varied agronomic characteristics were selected and inoculated with different strains of B. point Japonicum, and the experimental design and conditions. This article was carried out in two different localizations for two consecutive years to observe variations between seasons, inoculations methods, followed standardized protocols to ensure consistency. And finally is data analysis methods. We use statistical analysis, include ANOVA and post-hoc test to identify significant difference between treatments using SPSS statistical software. The next is a characterization of the soil used in the studies. The pH values of the soils used in the glass house in both seasons were natural. The pH values of the soil in Ignea were acidic in nature in both seasons, while in Ibadan, the pH values were slightly acidic. The organic carbon percentage was determined using the Wilkley black charming acid with oxidation methods. The P in the soil was in the soil was determined using the wet digestion method. The postporums in the soil used in the glass house was low, while a high percentage of P was recorded in the soil used in the field. And in in both in both localizations and seasons, ranging for uh, 15.5 um, and the 15 to ppm. Figure 1 shows the cultivations of inoculate BGM in a sterile and non-sterile soil and in soils in both localizations, Ibadan and Igne. Available nitrogen in the soil was determined using the Kecknell methods, and the results obtained showed that the nitrogen in the soil in the glass house was low in both seasons. Um, in the figure 1A genotypes in a sterile and non-sterile soil. B is a genotypes inoculate in Ibodan. C is a genotypes inoculate in Ignea. The calcium in the soil used in the glasshouse was extremely high, while the sodium in the field in Ibadan was considered normal. In the table 1, the magnesium present in the soil used for the glasshouse experiments was high in both sterile and non-sterile soil in both seasons. Here, mm, magnesium values were obtained in ignem in both seasons, while lower qualities of magnesium were obtained in Ibadan in both seasons. In the table 1, the soil textural class shows that the soil used both in the glasshouse and in the field was a loamy sand, and the biological properties, which include fungi, were determined using the sucrose density gradient centrifugation methods, and which involve the use of sucrose to isolate available fungi in the soil. The available spore was determined using serving and decantic methods to spore it count in 100 grams. Soil was achieved using the counting methods under a decisions microscope. The soil texture and glass shows that the soil used in the glass house and the on the field in both localizations and seasons shows that the soil was loamy sand. The analysis revealed significant difference among beginning genotypes in response to inoculation with nitrogen fixing bacteria, particularly in nodulation and nitrogen fixation across different seasons and localizations, has no in table 2. Will some genotype interactions with strains and localizations did not show significant difference. Specific genotypes like TB is U 1739 and notable eager nodal counts strain factory uh, stow out in nodal weight among the strains test. Inoculation with bacterial strains um, proved more effective than using nitrogen fertilizer in enching nodule formation, and nitrogen fixation has evidencing by results is both PO and field studies, and the tables two, and the next table is 3. Next, in the this figure 2 is a reference show the nodulation results for the year 2 to, for the year 2020 across two geographical localizations. It especially mentioned that the Vigna genotype TBSU 1739 recorded higher nodal numbers with a mean value of 12.448, which was not significantly different for TVSU 475 with a mean value of the point of the then 10.88, but these values were significantly different for the BGN accessions inoculate in the study. This indicates that certain genotypes, particularly TBSU 1739, had notable better nodulation performance compared to others in the same conditions and year. In the table 3 assess the impact of different nitrogen fixation bacteria strains on nodulation and nitrogen fixation of BGN genotypes across two seasons and localizations. Is Ibadan and Iken. The text in the article mentions that the RACA 6 and USDA 110 strains do not show significant difference between um, them in terms of the amount of nitrogen fixed, but they do significantly outperform other nitrogen fixation bacteria strains. Nitrogen fertilizer applications is urea and unequally controls in both localizations and seasons, as recorded in Table 3. Additionally, um, additionally, um, it is noted that there are no significant difference among the bacterial street nitrogen fertilizer and inoculate control in terms of nodal weight in both seasons and localizations. This lack of difference in nodal weight could be attribute to the activity in indigenous rhizobia, also noduling the legume, as discussed in the same talk. Next, and in the table 4, the results revealed that the inoculations of BGN and genotypes with strain significantly in aged nodulation and nitrogen fixation of legumes compared with the nitrogen fertilizer applied and the uniculate control in the table 4, and the intersections of the TVSU 1698 with FE 3 streets and then see the nodal number recorded compared the other genotypes with the straight intersections in the next in this table for the his nodal wave was recorded in the intersections of TVSU 1698 with control as a result of the indigenous rhizobia present in the soil used. Um, the highest nitrogen fixed was recorded in the interaction of TVSU1 1606 with RICA 6 compared to other genotypes with strings in interaction. Now, moving onto the discussion section, we have table 5. In the table 5 shows we observed a significant increase in the number and weight of noodles in 2020 compared to 2019. These suggest improved adaptations and effectiveness of the strain under specific conditions. Now, in this table 6, eager significant difference were recorded among inoculate BGN genotypes TVSU 787, TVSU 475, TV and TVSU 1007 739 in the bot experiment on inoculation on nodulation and nitrogen fixations and were also recorded in the field studies. There were no significant difference recorded among TVSU 787, TVSU 1739, TVSU 3005, TVSU 1606, and TVSU 300. 78 in the number of nodules observed in the glasshouse. Furthermore, there were no significant differences recorded among TBSU 475 and 506 and TBSU 1698 in the number of nodules in the last house, but they were a significantly higher than TVSU 365 and TVSU 710, which are not significantly different in the number of nodules recorded. There were also no significant difference recorded among TBSU 475, TBSU 1606, and TBSU 1698, and TBSU 365 and TBSU 710 in the moon nitrogen derived for the atmosphere, but it was significantly higher than other inoculation began other inoculate began genotypes in the glasshouse. In the table 7 shows that the inoculation of nitrogen fixing bacteria in the glasshouse did not result in significant difference in nodulation and nitrogen fixation compared to each other, but these were significantly higher than those observed with nitrogen fertilizer application and unicolored controls. A significant difference was recorded among the strains inoculated in terms of nodule number, uh, nodule weight, and nitrogen fixed. Moreover, significant differences were recorded in soil status, seasons, and some interaction in the glasshouse. In the table 8, the soil analysis results after growing the BGN genotypes Bambara groundnut eventually revealed that inoculation with strains had a significant effect on the soil even after uptake and harvesting of the legume with high nitrogen content, organic carbon, and other soil pro- properties. Next, the results present in figure 3 indicate that the TVSU 1739 genotype demonstrate the most significant difference in nodule numbers across both localizations and season compared to other Bambara groundnut genotypes. Additional TBSU 475 showed a greater significant difference in nodule numbers than TBSU 1698, which in turn was significantly higher than other Bambara groundnut genotypes across both localizations and seasons. There were no significant difference in nodal numbers between TBSU 710 and TBSU 1606 in any of the localization or seasons. Um, Finally, the genotype TBSU 506 recorded the last number of nodules in a, in in a localizations and seasons. Finally, in conclusions, respectfully, figure 4 highlights the difference in the amount of nitrogen fixed by various Bambara groundnut genotypes across different localizations and seasons. Notable TBSU 787 recorded the highest values of the nitrogen fixation, which were not significantly different from those of TBSU 1698. However, um, these values were significantly higher than those recorded for the other Bambara groundnut genotypes in the both localizations and seasons has shown and the figure 4 and the application of nitrogen fixing bacterial strains to begin genotypes significantly bo- boost, boost the ability to form nodules and fix atmospheric nitrogen, um, coating legumes sends with these bacteria allows them to establish a symbolic relationship with the legume roots where they transfer atmospheric nitrogen into a form the plants can use, op- optimizing nitrogen fixations. This process not only enhances the crop yield but also contributes of the food security by mitigating food shortages. Consequently, substituting chemical fertilizers with these bacterial strains can enhance nodulation and nitrogen fixation in begin genotypes without leaving harmful residues in the soil as chemical fertilizer. However, the main changes inoculate the limited availability of these effective strains at, at research facilities and their accessibility to the primary users and such as rural farmers. Finally, we have the reference of the article. Thank you very much for your attention.